Hello, everyone. In this video, we're going to look at example 3 from our notes on section 2.6, derivative of inverse functions. So in this example, we're going to be using these derivative formulas on the previous page, these nice boxes that we just filled out in the previous video. So let's take a look. So part A, we're asked to compute, or for each of these problems, we're asked to find the derivative. So part A, we're given the function y equals the natural log of sine of x to the power of 3. So first of all, notice that we have a composition of functions here. We can let u represent the inside of our power function u cubed. And then inside of that, we see we have another u, let's call v, inside of the natural log. So we have a composition of 3 functions here. Our furthest inside function is sine x. Then we have ln of v. Then we have to the power of 3. So we need to use the chain rule. To do that, we first compute the derivative of the outside function. So we have derivative with respect to x is equal to the derivative of u cubed. So the 3 comes down. And then our u here is ln of sine of x. Then we subtract 1 from that exponent. So then we get 2 here. And then we need to take the derivative of the inside, ln of sine of x with respect to x. So just to color code this a little bit more, here's our u function, our kind of first u function. So we've unwrapped one layer, but now we have to compute the derivative of this next term. So here we see that we have another composition. So I'm going to use a different color and go to the side here. So now I have ln of sine of x, and I want to compute the derivative. So notice I have an inside function that I'm going to call v. So then the derivative is going to be the derivative of ln with respect to v. So let's recall what that is. Move back in my notes. Derivative of ln is just 1 over the inside. So that's going to be 1 over v, which is sine of x, times the derivative of sine of x. Recall, we're using chain rule again here. So we need to compute the derivative of the outside function times the derivative of the inside function. So we're almost there. We have 1 over sine of x, and then recall derivative of sine is cosine. So that becomes cosine x over sine x. And going back to our definitions in trig, that's equivalent to cotangent of x. So if we back up here, so what we just did was this derivative. So we can put that in here into our work. So this becomes 3 ln of sine of x squared times cotangent of x. So that cleans up rather nicely. And our solution is, or our derivative is here. Awesome. So please pause, rewatch that part, and we're going to continue on to part B when you're ready. Okay, so in part B, we're given the function y equals arc sine of square root of x times ln of x. So notice that our kind of overall operation here, we do have a composition going on here, but overall we have a product. So we need to use the product rule. So the product rule is going to be our first step in unwrapping this derivative. So we can use then the product rule. We'll have our first function, arc sine times root x times derivative of ln of x plus ln of x times the derivative of arc sine of root x with respect to x. So we know from the formula, the derivative of ln is 1 over x. So now we just need to compute the derivative of arc sine of root x. I'm going to put a star and I'm going to compute it down here so we have more room. So we're looking at the derivative of arc sine of root x with respect to x. So we can recognize this as a composition here. So our inside function u is root x. So to compute the derivative, we need the derivative of arc sine. So where would we find that? Back up here in our notes. Derivative of arc sine of x is 1 over square root of 1 minus that x. So let me write that down for us. So we have 1 over square root of 1 minus u squared. So I'm using u here because we have an inside function. We don't just have arc sine of x, we have arc sine of root x. So we'll fill that in here in just a moment, but I'm just going to put u so it doesn't look too scary just yet. And we need to multiply by the derivative of root x, derivative of u. So recall, if we have root x, that's the same thing as x to the 1/2. This is equal to, just this derivative part is equal to the derivative of x to the 1/2 with respect to x. So using the power rule, our 1/2 comes down and we have x to the negative 1/2 now, which is just 1 over 2 root x. The negative in the exponent makes the base x go into the denominator, and that 1/2 exponent gives us the square root. So let's clean this up now. So this becomes 1 over square root of 1 minus root x squared times 1 over 2 root x. So now we can simplify because we have a squaring and a square root here. So that becomes just x. So now if we have square root and we're squaring that, that's just equal to x itself. So this becomes 1 over square root of 1 minus x times 1 over 2 root x. So let's go ahead and fill that up, fill that in upstairs where we need it. So this becomes arc sine of root x over x. Rather than multiplying by 1 over x, I can just divide by x plus the ln of x all over root 1 minus x. Sure, everything gets in a root times 2 times root x. And now one thing I'll note, because we're often curious, okay, have I simplified enough? Well, whenever I see that we have multiplied 2 square roots, I can combine those factors, multiply them together and put them under 1 square root. So this is equivalent to square root of 1 minus x times x times 2. So either form that you saw there is perfectly okay. The important thing that we're focusing on in this lesson is computing those derivatives. I'm going to box that here for our final answer. Awesome, great work. I know these derivatives get pretty hairy and messy, so just make sure you're taking it slow, pause the video, rewatch any of these parts. And the more practice you do, the more comfortable you will become. All right, great work, everyone.